Hello everybody, and welcome to Houdini to Maya Particle Instancers and Attributes. I'm Guy, your sensei and leader through this journey. In this tutorial, we will learn one way to export particles out of Houdini and import them into Maya. This is going to be a fairly technical tutorial, so please pay attention to the steps as you will need to follow them almost exactly to achieve the same results. Some of the key points covered in this tutorial: we will build a particle node tree with position, color, normal, scale, radius, and ID attributes, after which we're going to export the particles to an Alembic format. We'll then build a simple file importer subnet in Houdini and use Houdini Engine in Maya to import our particles as an n-particle object animation. We'll use an instancer in Maya to instance our geometry onto our particles that were exported out of Houdini. We will learn some of the nuances, setups, and render engine quirks to shade and texture our particle systems. We will show methods to render shaders using the CD values in Arnold, V-Ray, RenderMan, and Redshift. Some important notes to consider: Houdini particles to Maya do not support Alembic as animation as far as I know, and therefore the only way to do an animation is to export a BGeo.sc sequence out of Houdini using the ROP geometry output. This is my GitHub page where you will find a detailed document containing all of the notes and steps for each of the sections I will be presenting. You can see here some important notes, as well as the steps we will go over to cache our N particles. Here are some of the render engine steps, as well as some of the quirks for each of the render engines we'll go over. Here's a simple table showing you what Houdini attribute converts over to what Maya attribute, as well as the data type and the description. And here is some of the Vex code that we will be using in our attribute wrangles in Houdini. On the bottom here, you will see an assets zip file to which you can download the entire project file and assets, as well as some of the references that were used in this tutorial. Okay, let's meet in the dojo and begin training. Before we begin, remember, may the horse be with you. Okay, so here I am in Houdini 21, where we will begin to set up our node tree. It's going to be very similar to one of our previous tutorials. So let's drop in the pig head. I'm just going to rename this Geo1, dive in, and let's change some of the settings. Let's go with hard. Now, right now, as you can see, there are no normal attributes. We're going to need normal attributes in order to calculate our rotations in Maya. So let's add a normals. And for this example, we're going to set the normals to points. View that, and we can see our normals working just fine. If we go to our geometry spreadsheet, we can see we have normal values on our points. And those are these points right here. We can view our normals. Perfect. Now our example is going to have some animation on it. So let's add a mountain node. In the mountain node, we're going to change some settings here. Let's view our mountain sop, hit play, and change some of the settings. Okay, amplitude 0.1. Let's scroll down and check animation, and maybe do a Perlin cloud. Pulse duration, let's do 2, slow it down a little bit. Okay, that looks good. Transform, let's move centroid to origin, and let's scale this maybe 10. Funny looking pig head. Perfect. Let's add a torus. These settings look good. The radius settings will match in Maya very well. Okay, let's add a copy to points, scene view, and we will copy our torus onto our pig head. View that, and there we go. Now if we select our copy to points and control middle mouse, we can see the attributes that got transferred over. Our positions. Going into the geometry spreadsheet, we can see everything got removed, including our normals. So what I'm going to do is I'm going to go here into the copy to points. Under apply to points by copying attributes, I'm just going to hit the star. And when I do that, our normals come back. Or what we can also do is we could undo that and just remove this section, the caret n, which when we do that, our normals will come back. Next, let's drop in a connectivity. Connectivity does is it's going to give each and every one of our points a class. Go back to copy to points and check pack and instance. So now we will have 2,789 points, including 0. View the connectivity. Now in our previous tutorial, we added random CD values, so we can do that as well. And we're going to run this over points, which is the standard. I'm going to copy the same Vex code I used. And for our wrangles, I'm going to hit C, and then I'm going to color them a bright pink, just so that I know that these are going to be the wrangles. Hit this button, create spare parameters. point. When we view our attribute wrangle, we can see our colors there. That's our CD value, and we get all of our CD values just like we did in our previous tutorial. Attribute randomize to randomize our colors for CD value only, keeping the other CD values. We're going to promote our attributes, our CD values, CD, CD2, CD3, and CD4 from point to vertex. Again, this is important for Maya. Now, if we go to geometry spreadsheet, we should see our normals and class positions all in our points and our color values all in our vertex. Now we know what this looks like from our previous tutorial. Alt click to add a dot, and we're going to add the ROP Alembic output. I'm going to save my file here, and when we go here, same thing. I'm going to save it as particle attributes.abc, and I'm going to save the current frame range, right click, delete channels, and maybe we'll just do up to frame 96. Now this is important. We have frame number 1 to frame number 96 because Houdini starts at frame 1. The first thing I'm going to do before I export is come here into Maya, and I'm going to make sure that our frame starts at 1. Sometimes the frame starts at 0, but just make sure it starts at 1. Okay, then I'm going to click save to disk. Here I am in Maya. I'm going to go to cache, Alembic cache, reference Alembic, and I'm going to reference our Alembic. Great, everything came over. So did our animation. It lags very slow, and we see our Alembic file right here. And we could do exactly how we did in our previous tutorial if we wanted to add CD values. Right now I have it checked to deform geometry. If I come back into Houdini, go into our export and select transform geometry, add an unpack node. We're going to transfer our CD values, and let's click save to disk. Okay, once we have that, go back into Maya, cache, Alembic cache, reference Alembic. Here we have our color values. Now the reason I wanted to show this is because in Houdini, look at all the points we're caching out. 802,231. And look at all of these color attributes per frame, and we have 96 frames. It's a lot of data. And of course, there are instances where you would want to just do the Alembic file. But now here's where things get interesting. What if I just wanted to export the particles? So let me take off the unpack, and we can view our particles. We have a particle for each instance. What if I just wanted to export just these particles and then do the instancing in Maya? Well, after training in the dojo for a couple days, I've finally figured out some awesome solutions. So don't bow to your sensei, but work with your sensei. Okay, let's completely forget the color set editor. And for this, we're gonna need Houdini Engine. So let's go to Windows Plugin Manager. Here, I just loaded Houdini Engine in Maya. And here on the top, we can see load asset and recent assets. All right, back into Houdini. If we want to just get these points, forget about the geometry. We just want the points as an animation. Let's go ahead and set that up right now. So after the attribute randomize, I'm going to add an add node, put that here in the middle. And if I click on the add node, go to points, check, delete geometry, but keep the points. And if we hit play, we still get the animation. Go into the geometry spreadsheet, we get no primitives. We don't even get the point num, but we do get the points. Now this is something specific to Maya. If we go here into particles and we check add particle system, let's control whether a particle system primitive is created. Because right now, if I click on here and I click save to disk, it's going to save it a whole lot quicker because it's just saving the points and not the geometry. So I'll come over here into Maya. If I go to cache, Alembic cache, reference Alembic, go to my directory, you see the file is a whole lot smaller. If I import it, you see we get a particle attribute geo. And what this is this is just a particle node. But you see we don't get any particles. That's because particles themselves don't translate over into Maya. Back into Houdini. Okay, I'm just going to rename some of these quick. So this one, if I remember, was the CD attribute. Now, in order to get this to work, we're going to have to export our geometry using the ROP geometry output, because obviously Alembic, we can't get our particles. So I'll select that. Here, I'll do the same as I did before. Frame range, delete channels. This was 96 frames, and we'll save everything to this directory. Keep all the settings just as they are, and click save save to disk. Here in our folder, we get a geo sequence of our frame range from 1 to 96. Now back into Maya, if we click on Houdini Engine, we're going to be able to load an asset, but we need to load a Houdini asset library. That's going to be an HDA file, and we're going to need to create that. So let's go back into our object context and let's create that. Actually, all that we need is just a file reader node so that we can read our geometry sequence in Maya using Houdini Engine. So in our object context, let's just create a file node, and I'm going to name the file node maybe geo import, and the file node can just be geo file. I'm going to hit C for color, and for the HDA, maybe let's make it like an orange color, and I'm going to select that and click on this button here, create subnet from selected. This creates a subnet, geo importer, and in our subnet, right click, create digital asset. And here we're going to create a digital asset. Here's the save location. Let's hit create, and here we're in this, the operator type properties. Click on parameters, don't click anything, but what we're going to do is under create parameters, we're going to click from node, click on the file importer, the geo import, the geo file, and we can bring in maybe the geometry file and the reload geometry. We'll just bring those in here, and then we'll hide everything else. So we'll click that, control click that, and check invisible. So we just have our root geometry file and reload geometry button. Let's hit apply, let's hit accept. We go to assets, lock assets. Let's just lock the importer. Yes, let's save the changes, save our file, and again we can maybe make that orange, and now we can import this using Houdini Engine, which will allow us to import our particles. So back in Maya, we can now go to Houdini Engine, load asset. Here under documents, Houdini 21.0, we can click on OTLs, and here's our custom HDA, and let's hit open. When we do that, we can see we have our file importer, and that's right here. So right now it imported this geo that we saw here in Houdini, this thing right here, because that was what was custom loaded in the importer. If we go in, we click, you see here the geometry file and the reload geometry button. And now let's load our sequence. We can load our Alembic file, and then we check here, reload asset. Let's reload geometry, but reload asset. And now we get our particles in here. Wow, how cool is that? And it comes in as an N particle, but it doesn't animate. That's the missing thing with Alembic animate. We do see our colors came in. That's good. Okay, let's take a look at some more interesting things here. Here I'm in charcoal editor, or we can just click on your script editor at the bottom. And here's some Python. I'm going to click on the N particle node, and I'm just going to get some of the attributes. Now these are going to be particle attributes. And for example, we can get point size 2. We can get the normal direction. That should be 2 also. We can also get some of our other attributes in here too. If we go into per particle array attributes, we can get position, ramp position, velocity. But now look down here, we get our class, N, and our CD values, our RGBPP. These are the values that came over from Houdini. Back here on my GitHub page, what I did is I built a little chart and table that helped describe what exactly gets transferred over. So the Houdini P value for the particle translates into the position and world position attributes in Maya. The V, velocity, the force, acceleration, the N for the normal also gets transferred over to N. For the orient, we need to convert the orientation to a vector 3 float and name it rotation pp. This is going to come in later. The CD value actually translates over to the RGB pp. The PScale translates into the radius pp. So when querying attributes in Maya, we should use the values here in this chart, unless stated otherwise, or you renamed your attributes differently. We can query anything that comes from here. So in our Houdini file, if we click on our attribute promote and we click on here our points, you see we can query the P attribute, the class attribute, the N attribute, and just to make sure that they did transfer over, we can query the P attribute. Well, there is no attribute P because if we look here on the chart, the P translates into position and world position. So if we query position, yes, we see our position values transferred over. That's -5, 4, and 2. And in Houdini, you see we get, yes, -5, 4, and -2. We can query our class attribute. Yep, 0, 1, 2, 3, 4, 5, 6, 7. Same thing here. 1, 2, 3, 4, 5, 6, 7. it. We can query our N for our normals. Yep, our normals get transferred over. Can we do our CD? Aha, no, we can't. And the reason is because in our vertices, we see we get the columns, but we don't get any data. The data didn't transfer over. And why that is because in our add node, when we selected delete geometry but keep the points, our point num disappeared. If I uncheck it, our point num comes back. And in our attribute promote, we get the values. So let's check that again. Our point nums go away. But if we come back here to particles and check add particle system, that's going to add our particle system back. And now if we click on attribute promote, our values come back for CD. So let's re-export our Alembic. So let's reload the asset, sync asset to get my particles. My CD value should have transferred over. I'll come here to my N particle, click on particle attributes array. Yeah, we got the values here, but let's see if our CD came in. No object matches the name CD, but our CD2 came. And the reason is on our table, we see CD, the color value, comes in as RGB PP. So if we do that, RGB PP, yes, we get our values. This is good. So this is just some ways to check and make sure that your attributes are transferring over from Houdini to Maya. But as we mentioned before, we don't get the animation. So if we come here into our Houdini asset and we come into our exported BGeo.sc, we reload it. We get the same particles, no animation, but here in our raw geometry output, we can see here, here's the path, but we can use the $F in our Houdini asset here to replace the .1 with the $F, hit enter. Let's reload the asset. If for whatever reason your Houdini engine isn't working, just go to preferences, click on named pipe, auto start server, and hit save. Now nothing's playing, but if we uncheck this button here, cached playback toggle, when we turn that off and we hit play, now we get our animated particles. Now here's some of the classes that we see that was brought over, but we don't have a rotation yet. Rotation in Maya comes in under rotation PP. So if we click on add dynamic attributes general particle, you see we get rotation PP. If we hit OK, that'll add it here, rotation PP. And if we run that, we get all zeros. But here, if you remember, if we disable this add, you see our elements have rotations to them. There's rotation values, orient values, but they're not carried over because they were never in our attribute spreadsheet. And so we need to add some more wrangles. So there's a couple ways to get our rotation values. If you already have an orient value coming in and out of a simulation, then that's good. But if you don't have an orient, then let's make one here. Obviously there's rotation values, but we don't have them carried over from our copy to points. So let's add a wrangle and we can call this orient attribute wrangle, and I'll color that with pink. Because in our scenes here, we do get point normals. Under display, visualize, guides, if we scale our normals, we do get normal values. So we can use that. So this is the vex. We just add an up vector in the y, and we can use a quaternion make transform based on the normal and the up value and put that into our orient. If we come down here to our last node before the export, the attribute promote, we can see now that our points have orient value. Now these orient values are quaternions, and you may have an orient, a quaternion value, but unfortunately in Maya's a rotate PP, that is not a quaternion, that's a vector 3. So if we control click here, we can see here our orient is a 4 float, a quaternion, but we need to make it into a vector. So after our orient, you may have an orient already. Let's make another attribute wrangle, and we'll call it rotation PP attribute wrangle. And again, we're going to paste this code. Now we could name this whatever we want, but since Maya is already looking for the rotation PP right here, since it's already a native value, and I did include it here under orient, it doesn't convert over. And so for the notes in the description, I said we need to convert the quaternion rotation to a vector 3 and name it rotation PP. And so that is what I did here. Just for the sake of it being native to Maya, we'll name it rotation. When we click off, we have our rotation PP. Now it's very important to make that a vector, because if we don't, well, it's just going to be a single value. So here we go. And now this is set up for Maya. And then if we come down here and re-export, save to a disk, our geometry, then come back here into Maya and click reload. And then we can run our rotation PP, and look, now our values come in. Now we have our rotations. What we're going to do is we're going to create an instancer in Maya, and we're going to instance our own geometry on these particles. And we're just setting this up. Now there's two other things missing: PScale and an instance ID. Now why do I need PScale? Well, right now, if we come back into Maya and we do scale, we see PScale converts over to radius pp. So if we take a look at radius pp, there is no radius on our particles. If we go to general, we do see a radius pp here, and we could add it and we could run it, and we see we get a radius of 0.2. But for PScale, the value should actually be 1, right? We could make that value be anything we want to. But to make it match and to make it convert over, if you have a Houdini setup already, maybe you have a simulation already, you'd want that PScale value to transfer over. In Maya, there's another attribute called particle ID. This particle ID is a little similar to our class value, but each particle has a different ID number. 1, 0, 1, 2, 3, 4, 5. And so if we were using an instancer in Maya, we could instance based on particle IDs. Well, what that means in Houdini, let's turn off our add. Now we see here we have different objects, but what if we wanted multiple objects in different locations? Like, let's just say you have a particle simulation with different objects on particles. Well, you could use the ID in your instancer in Maya to say, well, I want some to be cubes, some to be squares. And in order to set that up in Houdini, we need to make that variable. But as a side note, it works in V-Ray, it works in RenderMan, and I do believe it works in Redshift. But in Arnold render, it gets confused. So you can't use particle ID. See right here, ID, you could use particle ID if you're doing any of the other renders, but just to make it safe, I'm gonna call it instance ID. That's creating a brand new attribute because, yeah, and you can try this out yourself if you want to see, but if you used particle ID and then you rendered using Arnold, it gets very confused and it doesn't render correctly. So we're going to combine our PScale and our instance ID into one wrangle, and I'm gonna copy and paste my code. And again, here's the note about particle ID, and so I just named it an integer instance ID. And if I check here, create spare parameters, what it's going to do is it's going to create ramps, and it's going to create different PScale values randomly according to this slider here. If I come down here to attribute promote and I view my spreadsheet, you see we get the instance ID. Now we don't get any PScale values. The number of instances is 0. And now let's move that over to 1 because we do want 1 instance. As you see, if we start to increase this number, you see the instance IDs increase randomly. So for each ID, we could attach essentially a different object. But let's just do 2 instances for now. We can create something like this. In our ramp ratio, it's right here for the index. I can create a graph like this, and we could move to 1. Look at our instance IDs. 2. If I click 3, you see we have 0, 1, and 2. 4, we have 0, 1, 2, and 3. But for now, let's just do 2 instances. And then I'm going to set the ramp here like this. So either the PScale is going to be 0 or 1. And you can see here, if I start to change this, some of our particles come back. So let's just make them very small. We'll do 3. And then maybe here we could also do 0.3. And then in our attribute spreadsheet, basically either the PScale is going to be 1 or 0.3. So for our object ID for 0, it's going to be 0.3. For object ID 1, it's going to be 1. And we could adjust these however we want. And actually, for a pig head, let's turn this into maybe like an easy, so that we could easily see if they're big or small, right? And again, you may already have PScale and custom IDs for your particles, but I'm just building this for the purpose of the demonstration. And that's it for our setup here in Houdini. If we click on our attribute promote, we have all of our attributes that need to come over. We have our position value, our class values, just in case we wanted to break up even more. And we have our instance IDs, we have our normals, our orient, our rotation, and here we have all of our color data. We could get rid of orient if we wanted to. We don't necessarily need it. We could get rid of it downstream if we wanted to with an attribute delete. For a point value, we can delete orient if we don't want it. Now I'm going to show you a different way to make the rotation value. You don't have to use Vex. The first way that I did it was actually using a point FOP. I'll show you how to do it that way in case you like point FOPs. So we can connect our connectivity here, and you can see we have nothing, but if we dive into our point FOP, we don't need these, and we can bring in a parameter, and then I can connect the orient that we created, or your own orient, into here, create a parameter, orient, and it was a for float, I believe. Let's call that parameter, and there's a function called Quaternion to matrix, connect that, and then extract xform. So we can connect the matrix to the xform, and then we can bind export the rotation value. So we want the rotation out, and look, here we get some values. And for here, for the export, we can just call it rotation pp, and we want to make sure that it's 3 floats, and there you go, we have our rotation value, and it's the same here. So if I click here and view it, this code is the same as this point VOP. So it's up to you, whichever one you want. Rotation pp VOP. But we're going to use Vex, because Vex I like a little better. Come in here, and let's export everything. I'm back into Maya. Now remember the particle ID, right? If we come up to our Houdini asset, reload asset down here. Looks like we get some spheres. That's cool, and they move. But for our BGeo, let's turn back on our add and re-export. Come back into Maya, reload the geometry, reload the asset. Here again, we get our points, but our color data is missing. When we did our attribute delete, it deleted our color values as well. I don't need it. So just make sure in the add node, you have add particle system, and our color values should now return. Save to disk, back in Maya, select the Houdini asset, sync asset, or reload. And now our color values should return. RGB, PP. Yep. Radius, PP. That's from our PScale values. You can see they transferred over. You get 1 or 0.3. Instance ID. Yep, it's either 0 or 1. And now we can get into something a little more interesting, because we have our particle simulation from Houdini. Let's instance Maya geometry onto these particles. To do that, I'm going to hit Control Tab. That's my Cosmos plugin for Maya. I'm going to create just a cube. And remember, P-scale value corresponds to the value, scale value here in Maya. And then maybe I'll create a torus, because we had 2 particle IDs. I'll hide them. Let's start with our cube. Select the cube, Control select our particles, Control Tab and click Instancer. It's under N Particles Instancer. So here in the menu set, we can click FX, and we can just stay here because we'll be using a lot of our N Particles menu. But if you go to N Particles, you can see our instancer. And now, look at that. We have cubes on our pig head. And I'll just here under the display, click wireframe on shaded, and they move. I'm going to click here in the attribute editor under instancer. I'm going to copy this tab, make it a little smaller here so we can see what instances we have. You can see we have the P cube 1. Now, if I added the torus, nothing happened yet, because we have to use our attributes, such as instance ID. It shows you the IDs here, 0 and 1. These are the geometry references. Now for the remainder, I'd like to stay here under per particle array attributes. You can see I added dynamic attributes general. I added the rotation PP and the radius PP, just in case they weren't there. But now that we created an instancer, under here, we see the instancer tab. You can see we have these parameters here. Here's where we can plug in our attributes from Houdini. And if we wanted to, we could allow all data types in case we don't see any of them here. Now our world positions are already connected. Those were our positions here. We could either use world position or position. They're exactly the same. In order to use our P-scale value, select scale. And if you remember what that was, click allow all data types. For scale, that was radius PP. Now when we do that, you see our scale changed. Some of them are 1 and some of them are 0.3. How about object index? Well, we can use particle ID, but since the attribute in Houdini, we named it to instance ID. When we do that, you see we get some of them are toruses and some of them are squares. And I can reorder these if I wanted to switch them around. How cool is that? It's working. Now the rotations, select it, and now we can go down here to rotation PP. Once we do that, we get our rotations. Can we go even further? Yes. Let's take a look at our GitHub page and see what we've covered so far. Well, we've built out everything here up to this point. Number 3, we built our attributes, we incorporated Houdini Engine, we used our instancer, and next we're going to look at how we can shade our particles in our render engines using the CD values. And as a final note, we're going to learn about caching, just in case you wanted to ship your project off, maybe to an artist or a machine that doesn't have Houdini or Houdini Engine. Okay, our animation is still playing, that's fantastic, but there's no colors on them. We can shade these, but wouldn't it be better if we could shade them according to our CD values? Well, yeah, of course. We have our RGB PP and our CD values that we could use. Okay, let's load our renderers. I'm gonna load some lights for all of my renderers. Let's create maybe Pixar dome light, V-Ray dome light. Arnold, let's create an Arnold physical sky. I'll hide the other ones, and let's work with Arnold first. So let's work with the shaders. We'll need to create an AI standard surface, and for V-Ray and Arnold, we need to create the particle sampler info, because in particle sampler info, if we scroll down here, you see the RGB PP value, and we can connect this to the base color of the Arnold shader. I'll switch my render engine over to Arnold, which it is, and if I hit Arnold render, you see this weird thing comes up. Go to attribute editor, increase my light. You see we get color particle dots, but we don't get shaders on our cubes because we need to click on our cube and assign to selection, and it's black. Now remember, the particle info here is still very important to connect it into our base color, but the main reason why is because in our N particle system here, under Arnold, we have some options here that we need to mess around with, namely 2 of them. First one, let's turn off primary visibility so we don't see our color circles. And the next thing we need to do is down here where it says export attributes, RGB, PP, enter, and there we go. Colors transferred over from Houdini. Perfect. Let's stop Arnold. And of course, we could assign a different shader to our torus. We can assign the same shader if we wanted to, and, well, make our toruses different colors as well. Okay, let's move on to V-Ray. So let's hide the AI dome light, show our V-Ray light, come back into our hypershade, and let's build the V-Ray material. So let's add a V-Ray material, clean this up a bit. We're still going to need our particle sampler, and what we're going to do is we're going to connect the RGB PP over to, let's go to other, and we need diffuse color, brilliant. Now if I switch my render engine to V-Ray and click on the IPR, same as before, black. There's 2 extra settings we need to set up for that. Again, click on our particle system, our N particles up here on the top, click on attributes, V-Ray, per particle attribute export. Down here under extra attributes, check RGB, and of course the final thing is to actually assign the shader to the cubes. When we do that, boom, we get our colors now in V-Ray. Now, if we wanted to transfer our CD2, 3, and 4 values in V-Ray, in Houdini, in my CD wrangle, I renamed these CDPP just so that I can know that they're per particle attributes. After re-exporting and saving to disk, I wanted to figure out how I can get my other CD values here and use them CD2, CD3, CD4, and in V-Ray, this is how you do it. I'm going to add a general attribute. I'm going to add the user vector 1 PP, and down here I'm going to check use vector1 pp because color is a vector value. Now right now, if I run this code and check for user vector pp, you see everything is 0, so it's going to be black. And if I do cd2 pp, you can see we have our values here from cd2. So how do we transfer those values into a custom vector pp value? Exactly. So what we need to do first is write an expression here in the user vector pp value. So I can right click, create expression. I drag this line down here, and I'm just going to set that equal to cd2 pp. Actually, let's make it cd3 pp. Click create. That's going to create an expression here. Now, if we wanted to remove the expression, we can just click delete, and that'll remove it, but I don't want to delete it. We'll do CD3 PP, and that puts the expression here. So now we have our vector value, and we can bring it in to V-Ray using the per particle attribute export by selecting and check this right here. Then in our particle sampler info, instead of using our RGB, let's pay attention to our render as we do that. We drag our user vector into our color, and ta-da, we get our values from CD3. Now we can edit the expression here, and let's pay attention as we select it. We can actually use our RGB PP if we wanted. That'll just turn everything back into rainbow colors. If we did CD2 PP, everything's going to be black because CD2 PP references these torus values. So if I selected the torus and I applied the material, you can see now it affects the torus values. Going back here, let's change this to 3, and now we have our other color values in here. Now if we save this expression, close that, close V-Ray, let's hide our dome light and bring back Arnold and hit render. Down here, export attributes, we can export CD3 PP. Now CD3 PP is not in here, so we'll have to use user data color, and user data color we can type in CD3 PP, connect it, assign the shaders to our objects, connect them there, and now we can get our CD2 values. But let's put our RGB there, and we can leave this here if we wanted it, and let's move on to RenderMan. Okay, so we'll hide our dome, bring in Pixar's dome. So we did V-Ray, we did Arnold. Now let's go to RenderMan. We will create a Pixar surface. We can assign the shader to our objects. Go to render using RenderMan, click the IPR, we see it's gray. If I connect the RGB PP to the diffuse color, that doesn't do anything. So we can't use particle sampler info. That's a no-no. Like before, what we could use is the Pixar attribute or the primvar. If you remember from our previous tutorial, Pixar attribute or the primvar, either one, we can connect the primvar to the diffuse color, change the type to color, and it's green right now. But if we type in RGB PP, now in RenderMan, we get our objects. Now for RenderMan, if you want to use your other CD values, you need to connect them to your RGB PP value. Because in our primvar, I just can't set this to another value like CD3 PP, because if I do that, it's not going to render. It's just going to render green like we have here. So in order to make that work, the workaround is you right click on create expression, and for RGB PP, I can drag that down here and I can set that equal to CD3 PP. And when I hit edit, I can come back here and set that back to RGB PP. This is because RenderMan uses specific naming conventions. And if I do that, okay, now how to do this in RenderMan? Now if I wanted to use my custom CD values, it's currently not working for me in Maya, but here is what the RenderMan documents say to do. Again, this is using the primvar, and here in the documents, I'll provide a link to this page, but you can see we need to create a special attribute with this naming convention here, and it's a detailed page. I'll basically show you what that means here in Maya. There's also a video here, which I'll also provide a link, that shows it working in a previous version of RenderMan, but unfortunately I can't get it working right now. But here's essentially what you'd need to do. You'd go here and you'd add a dynamic attribute, and you would preface the name with RMan, capital C, meaning color. And what RenderMan render is supposed to do is flag this attribute as a color attribute, followed by the attribute name. Make sure you select vector and per particle array, and then add. What that'll do in your particle shape node here is that'll add the attribute here. Here in the primvar, you would essentially put the name of your variable. You wouldn't put RManC because the documents say to just include the name minus the special flag in the beginning. But if I do that and I run RenderMan, you can see here that I get the green color, which is shown down here, which basically means it can't find our named primvar. And I can't seem to make it work. Maybe this is a bug or something I just can't figure out. I didn't do it correctly. Not enough training in the dojo. Not quite sure. If it was working as as expected, then what I could do is come in here into my variable here, right click, create expression, and then here was our V-Ray custom that we did before, and then we could do something like this. We could basically set that variable to the attribute that we created in Houdini. And if I executed that, you see it added an expression. And if I go to Python script editor and hit enter, you can see that the colors are transferring over to that new variable. But unfortunately, right now it's not working and I can't get it to work. So if I do figure out a solution, or if I do figure out later on, I'll be sure to update you guys with maybe a quick video or a comment. Okay, so I'm just going to change this back to RGB PP because this is the value that's working. Hit render and there it is working. Okay, close everything out, and what I'm going to do is I'm going to hide my dome, and I'm going to switch my render engine back to V-Ray. Okay, hit IPR V-Ray, go into the shader selection, and assign the V-Ray material. Okay, here we are in the V-Ray render. It looks like it's working again, and of course we can change this PP3 to PP4. That'll change also to, and of course we can change this if we have other attributes coming in from Houdini, and this works with V-Ray. But now here's a question. Because I brought in my particles using Houdini Engine, my end particle node is connected to Houdini Engine. So if I wanted to transfer this project to another artist or work on it without Render Engine, maybe on a different machine, they must have all my Render Engine nodes in order to work with this. So the question becomes, how can I use my current end particle setup here, along with my instances, without using Houdini Engine? Well, here I am on my GitHub page where I provided some detailed steps in order to do this. You will need to cache out your end particle system and reattach it to the node after you take it out of Houdini Engine. You can follow the steps along if you want. So my recommended steps is to always have a project. So I can go to File, Project Window, and I can create a new project. And for this project, I'll just call it Project Attributes. I'll go into my current project directory, I'll select it, and then I'll hit Accept. Now what that does now is if I go to File, Save Scene As, it will save the scene according to my project directory here in the Scenes folder. So I could now save my scene here, and that's where you'll find the project from now on. It'll be inside the Particle Attributes folder. So this was the previous file here, and we can find the new one inside, of course, our project attributes, and you can see here in our scenes, you can find the project. And it's good to set up a project for this case. So that's step one. Notice when it created the project, it also created a cache folder. Now, when submitting to render engines, you should always have your caches inside cache folder, and you can see we have end cache or end particles, or if you have another kind of cache. Okay, let's stop the IPR and let's get this end particle out of Houdini Engine. Always save the scene before you do this because there is a high chance of Maya crashing for some reason. So just go up here and click on your particle node inside your Houdini asset, come up to the FX menu set and go to cache, create new cache. I'm going to go to edit and reset the settings. And as you can see here, because I have my project set, it'll automatically put it inside cache, end cache, and inside a folder called Particle Attributes, which is the name of my scene, and the cache name, which is the name of the node here. Here in my file explorer, you can see here under the project files, I have the particle attributes, which are inside the main directory. This contains all of the shaders and everything. But for the caching, I'm here under my Maya project. I can click on it and go to scenes. And here's my particle attributes scene without any of the shaders and textures. And it's going to put the cache inside this cache and cache folder. So here in Maya, I can click create. It's going to go through cache. And when it's done here, you can see it created the folder. And here's the cache for all the particles. If for some reason your cache isn't working, you may need to disconnect any of your expressions or delete your expressions. So you can go to create expression, just delete it and hit create. Now the next thing we can do is we can click our end cache and we can drag it outside of the Houdini asset folder, just like that. And it'll still play because it's connected. Then I'll come up here into the node editor. That's Windows Node Editor. And with the file cache selected, I'm going to click this button here and put in output connections. And you can see here that we are connected to some things here in the Houdini asset, such as output. And if we check our particle shape, we can see that current time is also connected to the Houdini asset. So what we want to do is we need to connect the out time of the time node. This is the Maya time node. And we need to connect that into our particle shape, just like this. That completely removes the time variable that was used from the Geo importer. The reason why it won't work is because we can do these steps out of order. So for example, we can connect out time into current time and then just just delete the Houdini asset and that'll work. I want to show you what happens if you don't. So let's say you have this connected and you just delete the Houdini asset. If I do that, what'll happen now is if I hit play, nothing will happen because current time is always going to be 1. But if I connect the out time from Maya's time node into the current time, hit stop and rewind, and we come here to the particle shape, go to time attributes, right click, you can now see it's connected to out time. It changes correctly. Now nothing is playing because we have to attach our cache to the end particle system. So to do that, select the particle system, go to encache, attach cache. Here it'll open up the encache and you should be in your particle attributes folder and you can see here the XML file. If we open the XML file and we hit play, now we can see our animation play. And I'll just set this to 96 so it'll loop. Perfect. Now your particles are animating without Houdini Engine. And you will need to transfer your cache directory along with your project. Make sure that the farm will read your XML file. And it's easy if you have everything packaged up inside a Maya project. And now everything here is bundled without the use of Houdini Engine. You can save this and ship it anywhere. Okay, that concludes this tutorial. I hope you learned something. To sum up what we did, we explained one way to export particles out of Houdini, including all of our rotation parameters, our PScales with custom values, our normals, instance IDs, so that we can have different instances on a particle instancer. We even exported and showed you how to do that with an Alembic format, but unfortunately we don't have animation with an Alembic format in particles. So we built a simple file importer subnet, which allowed us to use Houdini Engine in Maya to import our particles using the custom HDA. We used the instancer in Maya, which allowed us to instance Maya geometry onto our Houdini particles. We set up our attributes here in the instancer geometry replacement section so that it can correctly read the rotations, the instance ID, the scale, as well as the rotations. We learned how to create custom attributes. For our render engines, we learned how to shade using Arnold, V-Ray, and RenderMan. Just remember a couple key things. Always make sure that your Houdini's timeline and Maya's timeline start at the same time. In my case, it was 1. For V-Ray and for Maya, you can use the particle sampler info to connect the RGB value into the Arnold shader, or you can connect the user vector from the particle info into V-Ray's color. In the instancer for V-Ray, make sure you have per particle attribute export. Scroll down, come down here and check the RGB as well as the use vector 1 or 2 or 3 or 4, whatever ones you want. Make sure that when you create an attribute, you don't go to attributes add, but you come down here to add dynamic attribute general particle, and here you can add your user vector 1s, 2, 3, and 4, and then you can right click and create an expression, and you can set the user vector to your CD value or to an RGB PP value. When using RenderMan, we couldn't figure out how to do custom RGB values, but we did create a Pixar surface, and into the diffuse color we plugged the Pixar primvar with our variable name RGB PP so that we can get our instances to be shaded with our RGB PP values. In the project file, I saved particle attributes here in the primary directory, which contains all of our shaders and node networks. Right here, this is it in Maya, and for caching, I created a new directory. Inside scenes is where I saved my scene, and this is the scene, same exact as before, but without any of the shading networks. And here we demonstrated how to make a cache, how to apply the cache, and how to make sure that time is currently on our end particles. There's so many different ways of doing things, and a lot of artists are very creative in helping figure out new ways to do things. So I sincerely hope that you appreciated this tutorial. It included a lot of different techniques into one. Please continue to work on your craft and live long and prosper.